Great. So hello everyone, thank you for joining this session. Really appreciate it. Today we're going to be talking about Docker on ASP.NET Core. So basically this is going to cover .NET 3.1, Core 2.1, 3.1, 5 and 6, because basically everything is the same. So what are we going to be covering today? We're going to go through a small story so we can understand why do we need Docker. Then we're going to basically explain some of the main concepts of Docker, like container, images, repository, a Dockerfile, what do they do, how do they work together. And then we're going to be explaining the difference between Docker and virtual machines, because that's really important to understand and distinguish between them. Then how we can get Docker on our own laptop or development environment. We're going to go through the hello world of Docker, and then we're going to do a small ASP.NET API application, and we're going to add a Docker container to it. A small introduction about myself. I have 13 years of experience when it comes to development. I specialize in software as a service, or SaaS, and blockchain. I'm a YouTuber, very small YouTuber, but still. I'm Lebanese, and my favorite sport is Formula 1, go Mercedes, and my favorite food is burgers. This is my website, feel free to reach out to me, anything.
Is that vegan burgers?
Well, no, it's really good juicy burgers. That's the only meat that. Okay, so let's go through story time. So this is me, or this is us as developers, writing our own beautiful application, and it works perfectly on our machine. We finished it, we developed it, and it's amazing on our machine. What's come after development? Taking it to production after it passed testing. Or before even testing, we take to develop production. This is our cloud ops team trying to run our application on the server, and it completely crashed. It doesn't work. There's a lot of problems coming in, and no one knows what's going on. So there's going to be a major conflict between the developers and between the cloud ops team. The developer says the famous words, "It works on my machine." The cloud ops team doesn't really know what's going on. So what could be the main issues behind this? So there could be several issues. First, our application could be using some packages or some framework that server on production does not actually utilize. The operating system is different. So we could have built our application utilizing Windows, for example, and all of our environments are running Linux production environments, so that will not work. There could be some configuration differentiation. So it could be, for example, we have certain networking requirement or some kind of configuration that on the server does not exist, but on our development machine has. It could require some microservices set up. It needs some further, it could, for example, need Kubernetes. It could need any extra services for microservices in order for it to run. Or it could have networking issue, because we could have opened a lot of ports, but basically the production environment has a lot of limitations, so it will not work. So how can we fix this? We can actually utilize Docker, and this is where the story ends for today. So what is Docker? So basically Docker, it's a container management system. And when it comes to container management, we're gonna go into deep what is a container and how does it work. But for now, let's think about it. It's like think of it as boxes, and we have a system that manages all of our boxes. That lets us think about it this way. And basically, it allows us to create easily nice boxes, and we can move them anywhere we want. So containers, we can see here we have nice boxes. And basically, it's a system for us to have all of these boxes, and we can actually utilize them, and we can move them as we want without actually disturbing whatever is inside this box. And these boxes, we can actually utilize to put our application either on the cloud or on a QA environment, on a developer machine, anywhere we want. So these boxes basically are our containers, and we're going to go into what are a container. But for now, let's think of a container as a box. So this is the box, and we can see now the box is open. What does this box actually contain? So before we can think of a container, we need to think about an image. So an image is basically our application. It will contain everything from the source code, all of our custom configuration. That's why it works on our machine, does not work on production. It contains all of the runtime. For example, if it requires a certain version of the SDK, which exists, which we know it actually requires, but the other people would not know which version of the SDK. So that's, for example, the runtime engine and any other dependency that we might need. Let's say we are utilizing any different NuGet packages, or utilizing any node packages to run our application. All of these will come into this box. And basically, once they are in this box, it's completely sealed. We cannot move it. We cannot change it. If we want to add anything or we need to update anything, we need to create a new image. But basically, once this box is sealed, it's sealed forever. Or actually not forever, but it's sealed for our reasoning. So Basically, it's a way to put all of our application binary, which is our source code. It's basically, it allows us to create containers. We're gonna jump into what containers are, and as well, they are derived from base images. We're gonna discuss what base images right now. And they are generated through Dockerfile. So what is a Dockerfile? A Dockerfile here is basically like a instruction set, and the instruction set is basically us telling this box how it should fill itself. So we'll tell it, for example, first you need to put the code, then you need to do the configuration, then you need to put the dependency, and then you can install the runtime. So that's a Dockerfile. We're also going to jump really deeply into what a Dockerfile is. But this is right now an overview about what is a Docker image. In essence, it's basically our application inside a box, and basically this inside a physical box, if we want to think about it, and basically it contains all of our configuration, everything we want there. So you might think to yourself, okay, that was the image, but what is a container? A container is an instance of a box. What does that mean? Let's think about it in a much more object-oriented terms. So we have a class and we have a base class. Or for example, we have okay, we forgot to mention one thing, apologies. So we said here every image is basically derived from a base image. So let's think about this example as a class and a base class. So every box that we think here, it has some kind of an instruction set inside of it. And this instruction set is always derived from some kind of a base class or base image. So let's say we are building our ASP.NET Core application. In order for this box to know how it's gonna actually knows how it's gonna work with ASP.NET, it needs to actually get its instruction from a base image, or a base class in this case. And basically, these base images will contain all of the infrastructure for the SDK, for example, for how to configure .NET 3.1, what are the minimum requirements, all of these. And once this base image is inside the box that we want to implement, it will actually, by itself, it will know all of this configuration, and it will know how it actually utilize it. So I forgot to mention that point, that's why I went back. So what is a container? We can think of a container back in the object-oriented world as if we have a class and we're initiating an object. So basically, if we have a class, we can initiate as many objects as we want. There's nothing stopping us, or there's no limitation telling us we can only, for example, have 3 objects of this class or 4 objects of this class. We can initiate as many classes, as many objects as we want from that class, because basically that's what we can do. So basically, a container, it's an instance of a Docker image, and basically whenever we wanna run a Docker image, as soon as we type those 3 magical words to run an image, a new container, or basically a new instance of this image will be popped up. It is basically the executable package. So basically, once we execute or create a container of a Docker image, all of the executable, it will merge with the SDK. It will merge all with the configuration, and it will be able to run. When we are scaling our Docker image, or basically scaling our application, so right now we have created an instance of our Docker image, and we have our container. So, and this is the actual container that's going to be running on Azure, on AWS, on Kubernetes, or even on Google Cloud. So once we have that, if let's say we have this container which is serving, for example, 10 customers, and it's working magically. All of a sudden, there's Black Friday, and instead of like 10 customers coming to our site, we have 10,000 customers. So how are we going to be able to scale this application directly from one instance in order for us to serve all of these customers? All we need to do is just initiate new containers. And basically, once we initiate new containers, we don't really need to do all of the work all over again, because all of the work and all of the configuration are already in the Docker image. So once we initiate the multiple containers, we configure our web servers to handle them all, but basically we don't really need to worry about any of the other infrastructure other than configuring and managing those containers. That way we'll get all of the scalabilities that we want. And where does this Docker container runs? Well, they actually run on Windows and Linux, but let's face it, 90% of the cloud is all based on Linux, so mostly they run on Linux server. It's I haven't seen any company which actually utilizing Windows servers to actually run Docker containers. So, as we said, this is like a small summary to go over what's a Docker image and what is a Docker versus a Docker container. So as we said, a Docker image is like we can think about as the base image, And all of these are instances of that base image. So we can see here we have one Docker image and we have 4 containers running simultaneously from the same base image. And that base image will stay the same. So you might think to yourself, okay, great. We have a Docker image and we have 4 containers running. But what happens if, for example, I updated my code, I added a new feature, I want to publish it. What happened? Do I need to remove everything from this image and actually reinitialize them? No. That image it's going to be forgotten, and we have to create a new image with a new version number. So let's say this is our application version 1.1. We have to create a new image with version, for example, 2.1. And once we have created this new image, we have to initiate containers one at a time to actually remove all of these 4 containers. This process of swiping all the running container with the new ones, there's a lot of tools right now on the cloud which actually do all of this for us, which we don't really have to do manually. Specifically if you're running on Azure or AWS, and everything is automated from that point forward. If you want, you can still do all of the manual labor yourself. You can actually create your clusters and you can actually manage your own runtime, but nowadays there is no reason to do all of this manual work yourself. And if there's any question, please feel free to ask me as we go, because it's better to answer them on the spot. So, what's the benefit of having Docker containers? So first, it's secure. So as we said, let's think about that box. So once that box is actually closed and it's actually in production on our containers cloud, there's no way for us to actually change it or change anything inside of it. So basically, it's a closed box. So if we think right now of the current way we actually deploy our source code, we actually have to export our DLLs. And once we have exported the DLLs, we need to have an FTP to a server and then uploaded all of this FTP to that server. And from that point, actually, it's going to reside in a directory somewhere, and we have to point our web server to that directory so it will know how it works. But with this, it's a container in a box. Nothing can come in and out. And once it shuts down, and once it runs. So no matter how much we try to infiltrate it, it will not happen. So even if we try to upload illegitimate files to that container and try to run it, it will not work because it does not have the correct permission to run. It runs application in permission. So if we go back to this nice diagram, so all of these containers are running in isolation. So what does that mean? So let's take IIS, and let's take, for example, we have 3 applications, 3 instances of the application running simultaneously on IIS. So that IIS by itself is actually managing all of the threads for this application. And it's actually trying to divide resources for those applications to run simultaneously. As well, it's handling all of the infrastructure in order for it to manage the network and manage all of the security, as well managing all of the drive for it. And basically making sure that all of this is actually working directly at runtime. So IIS is doing a lot of the heavy lifting for us. But when it comes to actually having a container, when it's running in isolation, it basically, once we run a container, the OS, it will communicate directly with the kernel, and it tells, okay, this container will need, for example, 200 megabits of RAM, and it will need, for example, this level of storage. It will automatically be dedicated for us. And the processes that's going to go for it, it's going to be only dedicated for this container. It will not going to be changed from one to another. So it's going to have its own dedicated resources. It's going to run in isolation no matter what other containers are running on the same server. And it's going to be like its own little fence garden. So nothing can come in and out. There is a way where we can actually have containers speak with each other and actually have some kind of communication, but this has to be done from the configuration point of view when we're actually building those boxes. So basically what we can do, we can actually create some kind of a networking environment, and that networking environment will be able to make the Docker containers speak with each other, but that again go back to the actual development of the application. But natively, it's actually every single container run in isolation. So the next point is they are portable. It's very easy. It's very, very easy to create one Docker image and distribute it across hundreds of environments in like less than 10 minutes. If we're gonna think about it in old terms, that would not have been possible. If we wanna, for example, run our application on this Mac, on the Windows, on the Linux, in a QA environment, in a production, a pre-prod, there's different environments. If I want to run them all of them, it's going to take a lot of work. But with Docker containers, because they are so portable and so easy for us to manage, it's really one of the main benefits. Short startup time. Because Docker is the Docker daemon, which we're going to be exploring what a Docker daemon is directly communicating with the kernel of the operating system. So if it's, for example, running on a Linux, it will be directly speaking with the kernel. It automatically knows what it needs in order for it to run. So the startup time of our application is really, really fast. If we're, for example, trying to run it through a VM, we need to wait for the virtualization to kick in, then we need to make sure the resources are available, and then it will actually run the application. But with the containers, it's a complete opposite, because it has direct access to the kernel, so the startup time is really fast. And because it contains all of the SDKs and all of the configuration inside that one package, it does not really need to go look on the OS or look on the network to see all of the requirements that it needs are there or not. It already has everything it needs, and it already has everything that it wants, so it's going to run really fast. So my last point here is going to be less disk space. A Docker container usually takes up, I want to say 60% less than actually publishing the application, because it actually can compress the files. And if we're, for example, relying on a production environment, we can actually get a reduced version of the SDK that we need instead of having to install the full-fledged SDK on that server. So that will also save us a lot of space. So what is a Dockerfile? As we said, a Dockerfile is like the instruction list. Let's think about it as if we are cooking. So if we're cooking, we're going to say, okay, we need, for example, we need to boil water, we need to put pasta, and then we need to stir, and then it will be ready. It's similar to this. So this is a very simple, very straight to the point Dockerfile. And let's see what does it do, and basically we can explain it one by one. So first, as we said, every box that we build, it must have a parent box or a base box that is going to get all of instruction from. So again, every image that we create must have a base image. And because we are building a .NET image, we need to have the base image based on .NET. That's it. So when we put the from, it means that we are actually getting all of the information that we want from that base image that .NET provide. Then we need to specify a folder, because once we actually download that base image, we can think about it as if it's like a virtual machine. We can think about it in a way that it's an actual machine, and we have folders and directory inside of them. So once we have downloaded that base image, we actually put a folder inside that machine, so we can actually put our source code there. And then what do we want to do? So we got this image, base image, and we put a folder there, but our source code still exists on our current machine. So what do we need to do? We need to copy our source code from our machine, so it will go into that new image that we are trying to create. So that's what the command here. Basically, first we copy the CSproj file. You can argue that you want to copy everything, but usually it's a very good thing to separate the CSproj, because CSproj contain a lot of references, and it's really good for us to get all of the references, make sure they are correct before we can actually copy all of the rest. Because if our project is 200 megabytes, I'm trying to copy it from our application to from our machine to the Docker image, that will take time. But if we only copy the CSproj and run a .NET restore, and if there is anything which is not right, it will directly show to us that, okay, this NuGet package requires this kind of credentials, which will not work. We need to configure this. So it's always better to have the CSproj at first, and then once we have the CSproj, we can actually run the .NET restore to make sure that all of our packages that we want for this project will actually exist inside the new Docker image. Once we have done that, we have passed the two first checks. We have a folder. We have all of the NuGet packages, or all of the packages that we want inside this folder. Now it's time to copy our source code from our machine to our new image. So basically, also we do another copy. Once we do all of the copy, the logical sense is for us to create a published version, because basically we are treating this base image as a development machine. So we can actually have everything there for our development purposes. So once we have copied it, we run the simple command .NET publish as a release, and we create a new folder called out, so we can host everything there. As simple as that. So now we actually have a base image. It contained all of the correct instruction set for the SDK, because we got it from Microsoft.NET. Once we have that, we have got all of our packages, and we have restored them correctly. We have copied all of our source code there, and all of our source code exists, and we have published inside that image our project. But you might think to yourself, why are we bothering by actually publishing inside an image if we can actually just publish outside and copy whatever we published outside to that container? The reason is, if we are actually planning to have this production, have this application in production, and we have to make sure that it's running in the best way possible, because when we publish an application, it also refers back to what type of .NET SDK we have. And basically, based on that, once we publish it inside, it will take all of the right configuration from that base image in order for it to run inside that image. If we copy it, for example, if we publish it on our machine, and inside our development machine, we have 3.1, we have 5.0, for example, and we have 1.0, a version of .NET Core. It could be, for example, if your application on 3.1 and you have the SDK 5.0, you might utilize any of the functionality that 5.0 provide in order for you to publish this application. But if we're actually publishing it directly inside our container, you'll only know that's going to take only the right information for you. So once we publish it out, what do we need to do? We create another image. And this basically, the image here is going to be the final image that we're going to be utilizing. So all of this here up, we're just utilizing it as a buffer. So basically, we are preparing our image to have the final image. It's basically just a boilerplate. So basically, we are doing all of the work, making sure that all of our information are actually going to be published correctly. And finally, what we can do here is we can create a new base image. We create another folder inside of it. We decide which port we want to expose. And we can see here basically what we are copying is we're copying this published release to this new image, and that's it. So let's do a quick summary of what happened. We decided that we want to build a container of our application. Once we have created that container, we need the base image. So we got the base image from Microsoft. We created a folder inside this new box, and then we copied the CS proj. We did all of the restoration, made sure it's working correctly. Then basically we copied all of our source code. Once our source code is there, we published it to a folder inside that container. So now we have our development machine, and we have our base image here. The next step for us is to create another image next to that base image, and basically we're going to only copy from that image is the publish file, which we did here. And once we published it here, we specify which port with this new image we're going to actually utilize, and which is the entry point, which is what's the main DLL that's going to be running when we run the application. And basically, this is the random DLL that we have here. And once we have had it here, the application will be able to run. Does this make sense? Perfect. So all of these images that we are speaking of, for example, all of these all of these images must be somewhere, like this base image that we're going to be utilizing from Microsoft, or all of our images that we're going to have, they must live somewhere. So if we think of source code, where does it live? It usually lives in a code repo, like GitHub, GitLab, Bitbucket, so on and so forth. Similar to Docker images. For Docker images, it's called container registry. And basically, container registry, we can think about it similar to GitHub. It's like there is two parts of it. There's public and there's private. Public, it's all of the containers that all of those big companies want you to have, like Microsoft, Postgres, MySQL, Oracle, so on and so forth. They give you all of these base images for free, and they host it on Docker Hub for you. And it's really, really good for having. If, for example, us as people, as developers, we can publish as many as we want free images or public images for people to utilize, and we are, I think, allowed only one private image for our own personal usage, which is still very good because it's free and we don't have to pay anything. So basically, it's like a website. We're gonna go on the website right now, and you can see there is, I think by that time there was 5 million, I think now there are around 7 million public available images where you can actually utilize any base image that you want, and you can build your code based on that image. So what are the main benefits, or not benefits, characteristic of this container registry? It is stateless and highly scalable. So let's say, for example, I decide I'm a big company and I want to have all of my Docker images that I create to be hosted inside this Docker Hub or this container registry. What can I do? I can push all of my images there, and because it's a stateless, what does that mean? Once I upload my image to that registry, It does not, all of my configuration for it, of how I can connect to it, how I can download it, is completely saved there. There's no service was currently running in order for me to keep that image alive. It's completely stateless. So once it's there, it's there. Distribute Docker to different images, hosting all of the images at one stored location. So as we said, if we once I post that image, it will gonna live on that container registry. And let's say my QA team, my development team, my production team wants to have a copy of that image. All they need to do is connect to that registry and download that image. And with the, I think with the 3 lines of with the 3 words, they can actually get all of those images available on their machine. And similar to GitHub, there's a lot of online repository which provide us the container registry. The biggest one in the world is Dockerhub, which is open for everyone. If you're running on Azure or AWS, on Azure you can utilize Azure Container Management, which is already a provided service by them. On AWS, there is AKS, I think, which is also for Kubernetes. But all of the major cloud provider provide the container registry for you, so you can actually provide or upload your Docker images too. So, how does everything fit together? That's the main thing that we want to know. So first of all, we create our Dockerfile. And as we said, our Dockerfile is going to be our instruction set of how everything works together. Once we have created our Dockerfile, we execute one command. And through that one command, we create a Docker image. But that Docker image currently exists on our development machine. So what happens if I want to make it available? I need to push it to my container registry, which is either Docker Hub, Azure Container Registry, or so on and so forth. Else, I can execute or generate a container, which basically my application. So basically, if we think of containerization, we can think of it in all of these aspects. There are 4 main things that we have, which is basically the main, which is our Docker file, our Docker images, our registry, and our containers. These are the, I think, 4 principles. People might argue, but I believe these are the 4 principles of containerization. So, stepping away a bit from containerization, let us understand what's the difference between a virtual machine and a Docker container. So let's take it step by step. And for the simplicity's sake, we're gonna just think of these as Windows machines. So let's say I have 2 servers, server 1 and server 2. Both of them have shared the same hardware. So this has, for example, 2 gigs of RAM, 2 gigs of RAM, and 4 core CPUs and 4 core CPUs. Perfect. So both of them right now are the same. So let's go a step up. This one has Windows installed, let's say Windows Server 2016, and this has Windows Server 2016. Also, similarly, exactly the same way. Let's take it a step further. Here we can see that we have the hypervisor, and here we have the Docker engine. So what is the hypervisor? So if we're gonna, for example, create a virtual machine, we need some kind of a system that's gonna be managing all of our virtual machine. So we can create on a Windows server, we can create Linux, we can create different types of Windows server. And all of these machines, once we are creating them, we can see inside that configuration menu that we need to specify the number of RAM that we wanna provide. We wanna specify the number of the storage, how many cores of our CPU, all of these configuration will need to go into this. And how does the main operating system will be able to understand the requirement of these virtual machine? It needs to go through something called the hypervisor, which actually translates all of these requirements from the main operating system to the actual OS, so it will speak with the hardware. So the hypervisor here, we can think about it as a translation service of all of the requirement. So, okay, great. We're gonna go into this section right now. So I decide I wanna have a Linux environment, and a Windows environment. And from our 2 gigs of RAM, we said we're gonna give 500, 500, and 500. So in order for these machines to have 500, 500, 500, they will need to tell the hypervisor, please give me 500, please give me 500, please give me 500. The hypervisor will need to check with the OS and the hardware. Do we even have 500? Are we able to actually allocate 500 to all of these and then have enough resources for us to work as we should? If everything passed through, all of this configuration will take time, the OS will manage it, and will go back directly to the hardware, and basically those operating system will run. On the other hand, if we're running a Docker engine, we have something called a Docker daemon. And basically the Docker daemon here is what is running the application. So we can see that inside our Docker engine, there is nothing, it's gonna be relating all of the changes here. So let's say I have my application, my beautiful application that I have created earlier, I wanna install it on my Windows environment here. So basically it's gonna sit on top of my Windows environment with all of its configuration. So it's gonna be the application, configuration, operating system, hypervisor, OS, and hardware. On the other side, these app1 and configs are basically one box. The reason I put them like this so we can see the separation, but basically they are one box because they are inside the same Docker image. And because they are utilizing the Docker engine or the Docker daemon, and as we said, Docker has direct access to the kernel of the operating system, it does not really need to go through the hypervisor in order to do the translation. So the application will utilize Docker engine. The engine will speak with the kernel directly without any translation, and basically based on that there is not going to be any hardware allocation because the application will know by itself when it speaks with the engine, oh I need, instead of, because here we are adjusting for a complete operating system on top of an operating system, so it's going to require much more resources and much more heavier than actually running a single application. So here, for example, this can take up to 500 megabytes of RAM. This will take 15 megabytes of RAM or 50 megabytes of RAM. And we can see here the big difference between. So here the application will speak directly with the operating system. It will communicate with the hardware. The hardware will be able to satisfy it because it's much more reasonable, and the application will run. So this entire process, whenever we run Docker run, this could take, 3 seconds to do. If we're planning to run a hypervisor, that can take up to 8 minutes to run or 10 minutes. And all of that just because we're running the hypervisor, we're booting the operating system is doing all of its configuration, and at the end of all of that is actually running the application. While here, as soon as we said run, the requirement will go to the Docker engine, the Docker engine will directly speak with the kernel, and the application is booting. So from all of these, we can see the benefit that the Docker engine will give us. So we eliminated all of the operating systems, and we have eliminated the hypervisor. I'm not here trying to like demonize or telling you the virtual machine is bad and Docker is good. It's not the case. Virtual machines still have its reason to exist in the world, and Docker have its reason to execute. But a lot of our current implementation of virtual machine is an overkill for our application. And the cost of having a virtual machine is much more expensive than having a Docker container running. And if we come to business, at the end of the day, when we work for a company, we want to save them as much cost as we can and basically make our application as much optimized as we can. And for a simple application, if we're gonna through this process, all of this cost and effort, it's not only gonna be required you as a developer, it's gonna require infrastructure guys, networking, it's gonna require someone to manage the operating system, someone to manage the configuration, and someone to keep updating of the application. So that's a lot of work other than the actual hardware. But when it comes to actual Dockerization, all you need is one network administrator to do all of this. But again, virtual machines still have their place, and they're not dead yet. So how can we set up Docker on our machine? It's very simple. All we need to do is register an account on hub.docker.com forward sign up, and we can follow this link to actually download it. So what we're gonna be doing right now, I'm gonna open my terminal, clear, and I'm gonna make sure Docker is running on my machine. Just to take a few seconds. So if you take a look at the upper side of my screen here, you can see that I have like a small whale trying to like build itself. And we have seen like some nice boxes trying to jump and down. This means that Docker is being initialized. And once that it's being initialized, we can see that the boxes will stick on top. It will not move anymore. Another good aspect, we can see that now it's here in green. When we run it, it will be in yellow. So we're gonna execute this nice command that it will give us here. Docker getter starting, or we can run this nice simple command, Docker run hello world. So as you can see here inside my terminal, I don't have any special folders. I'm just on my root access of my terminal. If I type Docker run hello-world, let's see what happens. It's gonna tell me that it's unable to find that image locally. Let's go back up. It's telling me that's unable to find that image locally. It's gonna pull the latest image and then it's gonna execute it. Basically, it's telling me hello world and making sure that Docker exists. But okay, this is great, but what's going on here? Why did it give me this? So let us explain this process in detail.
If any of that text is important, can you blow it up a bit bigger? Is
Uh,
that possible?
let's see how we can blow up this edit. I'm not sure how to change the text of, let's see.
Well, you can just tell us
reference.
what's important about what it says.
Yeah.
We can't read it from here.
Apologies. So, font size, let's make this 22. See if that will make it better. Did it make it bigger? No. There's nothing really important here. So, tell you what, I can do this. Let's just create any new file and we can zoom in. Okay, let's close this, let's close this. Okay, so this is the output that's coming out. So we can see here that I ran this command. Is this clearer? Yeah. So I just ran this command, .NET run hello world, and I just got unable to find image, hello world, locally. And then automatically by itself, it starts pulling from library, hello world, and start doing all this work. Basically here it's just running that container in order for me to know that Docker Hub is running as it should. But this is what I'm really interested in. Unable to find local image locally and pulling and then actually running it. How did it know that it needs to do that? Let's take a step of what's happening in the background. So, I'm here in my terminal. I just type docker run hello world. What happened? As soon as I clicked on enter on my terminal, a command has went directly to my Docker daemon or Docker engine. And this is what we saw upstairs, the nice whale with jumping boxes. It went there. What is the role of a Docker engine inside my computer other than communicating with the kernel? It's gonna check all of the images that exist on my machine. It's gonna know, do I have this image here? I don't have this image here. Do I have this information or I don't have this information? So first of all, it tried to check for a program called hello world or an image called hello world. It checked locally, and after it checking, it checked, okay, I don't have it. So what happened here? Because Docker is basically called Docker and it's automatically connected to Docker Hub, it has a built-in connection directly to that Docker Hub connection, Docker Hub repository. It went to Docker Hub, it asked Docker Hub, do you have an image called hello world? Docker Hub, yes, sure I do. So because it's automatically connected with each other, so Docker Hub provided back that image to my machine, which is called hello world. Once it reached my machine again, basically the Docker daemon will do another check. Do I have this hello world locally on my machine? Yes, I do have it now. So what is it gonna do? It's gonna load it into memory, and it's gonna basically extract that image, and it's gonna run that image. And all of this basically, once it's extracting it, the Docker engine or the Docker daemon will know the basic requirement for that image to run. It will speak with the kernel of the operating system. In case with Mac OS, it was going to tell it, okay, I need 2 megabytes of RAM for me to run this application. Once it gets all of the information, it will show me back the output back on my screen. So all of this and all of this checking, it took basically, I don't know, half a second to execute, and that's on a personal computer. Imagine if you're actually running on a full-fledged server on the cloud. It will take milliseconds to all of this exist. So all of this basically happened really quickly. And this is a program which someone wrote called Hello World. Imagine, for example, for us, if I'm running, for example, my beautiful application, I type into it Docker run my beautiful application. It will go directly again to Docker daemon. It will check if I have it locally. If I don't, it will check with Docker Hub. If it doesn't find it with Docker Hub and I'm a developer and I have, for example, I'm using Azure, Docker is smart enough to know because I have already logged in with Azure. It will communicate with Azure to get from Azure Container Management. Or if I'm utilizing AWS, it will know that it will need to connect with AWS and check there. If it's find it, it will go back and it will actually do the same process. If it doesn't find it, it's going to tell me I have checked this place and I cannot find it there. So we need to change the configuration so it will be able to understand and to able to find it. So my last point here, I wanted to give you an overview of how to build an actual Docker image if you're interested. But basically, it's going to be a quick coding session. If you're interested, I can do it here. If not, okay, great. Let's sit down and let's start it. So, again, my favorite tool in the world is the terminal. And basically what I'm gonna do now, I'm gonna go to my desktop. This is just a setup. Inside my desktop, I'm gonna create a new folder. I'm gonna call it Demo Day. And I'm gonna go to this Demo Day folder. So we're gonna create a web API project and we're gonna be utilizing the beautiful .NET new keyword. So .NET new web API and we're gonna call it Leeds because we are in Leeds. And this should take a few seconds. And now we have our nice application. Now let's open it in .NET Code, .NET and Visual Studio Core. Yes, I trust. Okay, so as we can see here, this is .NET 6 by the way. So as we can see here, I have my normal structure, I have my controllers, I have my app settings, I have my program. I don't have startup class because it's all been removed in .NET 6 and everything I need is inside my program.cs. So what do I need to do in order for me to create a Docker file here and for actually to utilize my application? It's very, very simple. As we said, all I need to do is have my Docker file, which is my instruction list. So inside my root directory, I create a new file and I call it Dockerfile. As simple as that. As you can see, I'm not sure if it's visible. As soon as I type the Docker file, this icon, let me remove the E. So it was like this, like a normal generic file. As soon as I type Dockerfile, we can see it switched the icon to a small, nice whale. So right now, Visual Studio Code will actually recognize that I have a Docker file. And basically, it will know that it needs to have the IntelliSense in some sort for a Docker file. I highly suggest if you're going to utilizing Docker to install this Visual Studio Code repository extension. It's really, really nice and it's really useful. So let us compare what we need to do, what we have in that demo, and let me open it up. I already have it. Not this one. Apologies. I already have it here opened, so we can just explain and we can add it based on our application. So the first thing first, we said that we need a base image. And basically this example that I have on the right on the left, is on .NET 5 and it's going to be on .NET 6. So that's why I wanted to see how easy it is to do for both. So what I need to do is basically to create my application, but for .NET 6. And as we said, the first thing that I need to do is to have a base image because it's a .NET application, I need to have an SDK. But how I'm gonna find this base image? As we said, Docker Hub is the biggest Docker repositories in the world, so I can go directly to Docker Hub. And inside Docker Hub, I have this nice search place, and I can just type .NET. And I can see a lot of stuff coming in for .NET. So what I can do to minimize, I can type verified publisher, and still I get a lot. But I can see, for example, I have here Microsoft, so I click to Microsoft. And I can see Microsoft as function, so I click to Microsoft here. And I can see all of these libraries that Microsoft provide for me. Every single one of them. So what I want to do is, for example, I want to have the .NET one. So let me search here for the .NET. So there's 301 images only from Microsoft. So not other functions, .NET. see where it's gonna be. Or I can do something instead of just looking like this. I can utilize Google to find it faster, but I wanted to show you through that way. So we can put .NET SDK Docker image, and we can put .NET 6. And it directly took me there. Google is amazing. Okay. So now I directly went to the .NET SDK. I can see here that this is the latest version that I can utilize, and it's telling me this is the path, my MCR Microsoft /.NET and the version 6. If I scroll a bit down, we can see here that the different support. So for example, right now I'm gonna build my container on Linux because I'm running a Linux-based Docker version. So I can see here that I need to utilize one of these. But you can see here, it's not only utilizing the x86 architecture, it's utilizing ARM as well. So if I have as you said, IoT, which is running on ARM, I can actually utilize it from here. ARM32, if I, for example, have a nano server or Windows Core or any of this, so you can see that single image that I have or repository, it has all of these configurations which are already available for us out of the box. So we don't really need to do a lot of work. But for me right now, I'm gonna do with the generic one, which is this one here. Let's copy this and let's go back here. So let's get this again. And let's do the comparison next to each other. So first of all, as we said, I need the base image, and the keyword to get from the base image is from. And basically, with that auto keyword, you can see it says base image, and I'm gonna just specify my base image here. And once I do that, I need to give it a name, because this is, for example, Mohamad's development machine. And as we said, that base image is gonna have I need somehow to refer back to it. So I'm gonna call it build environment. I can call it whatever I want. I can call it, for example, Mickey Mouse as I want. It doesn't really matter. So as soon as I put the as, it means that this is gonna be, we can say like environment equal image equal build environment. So once I've done that, as we said, we need to create a folder. So how do you create a folder? We create a work directory, and basically I'm gonna have a new folder called app inside this new image. Once I created that, what do I need to do? As we said, we need to copy everything into, we need to copy the CS proj into this new image. But before we do all of that, which is something I forgot to mention, let us just try to run this application to see what does it do, so we can compare if it's actually running or not. So let's do .NET run. And now we're just running the application normally. Okay, now it's running, it's able to connect, and if I go right now to localhost, let's say 5229, it's not running. If we go to the controller, what is it, the controller? Weather forecast. Okay, so this is the controller, and we can see that we got a random JSON string giving us the random weather. So that's the application running without anything. So the goal is we want to build a Docker container and actually have the same results. So let's stop this and let's continue with our development journey. So now we have got our base image, we created our folder. The next step for us is to copy the CS proj file. So we're going to put copy, and then we'll have to put the star, which is going to be the flag to get any file that has the CS proj extension. And then basically put space and then /. So the space, so the // it's going to mean that it's going to paste it inside the root folder of the app. So because we have specified a directory called a folder called app, when we put // after it, it means that it's going to copy it to that app folder. So for example, if I put it to I don't know, Mohamad, it's gonna copy it to the Mohamad folder, but I don't want that. I want it to have it inside the root folder. So once I do that, I need to run a command to restore all of the requirements, and I can type .NET restore. and I save this. So one thing for us to do is to just make sure that everything is running as it should be. If I want to just keep testing my Docker file, I can just type docker run, because look, let me clear this up so we can see it more clearly. So here you can see I'm on the Leeds root folder, which is here, the same folder as this one. And basically what I run, if I type docker run right now, it's only 2 words. But what is going on if I type docker run? Because I have typed docker run here without any extra parameter, it will automatically assume that the Docker file it's looking for is going to be on the same directory as is. So if I type this, docker build, not docker run. If I type docker build without anything, just the dot at the end. Dot at the end means that it needs to look in this directory. And basically the docker build, it will automatically look for a Docker file inside this directory to build it. So if I type docker build right now, we can see something is going on. Basically, it's loading the definition of the Docker image. Let's go up so we can see it. So it's downloading this one, the SDK locally on my machine, .NET 6. It's gonna take some time to download. But basically what it's doing is it's checking on my machine first, as we said, does it have the SDK available inside my machine? No, it doesn't have it, so it's downloading it so it can actually utilize. I should have downloaded before the starting of this session. But
You can go to Dockerfile. Probably just already there.
yeah, the issue is okay, that's fine. It finished. Actually, it's still running, but this failed because it did not finish.
CS project.
CS. See? This is what happens when you code live in front of people watching you. So let's go back to the console terminal. So this is gonna still downloading. Oh no, let's try it right again. Okay, now it knew that this image is, I have it locally. So now basically it loaded the definition, it loaded this inside the Docker daemon. It actually found this .NET SDK and it loaded all of the metadata we can see here. It loaded everything that it needs from internally. So it did not connect to the internet. It actually loaded from my own machine. It loaded the build for the SDK. And basically once it done that, we can see it had actually created my folder. It copied everything related to the CS approach inside my root. It has run it successfully. And basically it told me that everything is running as it should be so far. Next, if we want to continue developing this, what do I need to do now? As we said, I need to copy my source code inside. So I'm going to use my copy dot forwards dot. So what does this mean? When I put a dot in front of the copy, it means that everything you have here, copy it inside. I don't care what it is, just copy it inside. And when, as we said before, the dot forward slash, it means that I copy it inside the root directory of basically the app folder here. So once I have that, what do I want to do? I want to basically run a publish. So I'm going to use the .NET keywords. So .NET publish -c release, and I'm going to put it in a folder, put it out. So again, if I want to test if this is working, I can just put docker build again. And we can see here it's basically much faster now because it's not doing all of the, it's not downloading anything. It automatically built it because I did not change any of this. So Docker is automatically saving the steps that I'm doing. So for example, let's say I'm keep adding on here. So every time I build, Docker will not need to do any of the changes, any of these. Docker will not need to execute any of these again because it already knows that it's the same version as the one that has done before. So it's only gonna load everything and then it's gonna run only this command. If I change anything here, or if I add any command here, it will rerun everything. But because I didn't, it's basically the same thing. It just continued. It cached it. So if we look here, we see the word cached, because from previous executions, it automatically knows the outcome of this, so it does not really have to do the work again. So it's saving resources from your own machine as well.
If there is any change in the CS project.
Yes, let's change right now here. So let's go to this class and let me add a new, for example, let's copy this one. And instead of temperature C, I'm gonna put temperature Fahrenheit, for example. Uh,
You've already got that.
okay, so call it temperature Mohamad. And as you notice here in the Docker file, I haven't changed anything. I only changed one single line. I added one single line inside the class, right? So right now, if I run the Docker build again, look what's gonna happen. So it automatically loaded my image from before because it's gonna be the same. Let's go to that one so we can see. So this one is basically gonna be the same from before. They're creating the directory app from before. The CS proj is from before, the restoration from before, but when we actually copied this one, you can see it's not has the cache anymore. It automatically, it recognizes, because this is the key aspect here that we really need to pay attention to. When it says here, transfer, where is it? Transferring context. So the context, what does it mean here? Once the first time it copied the context, it keeps like a, I forgot the terminology for it. It's like a hash, I forgot the name. It's like a thumbprint of every file it copies. And basically, whenever it copies it, it keeps a thumbprint of that number of files, the size, so you can make sure it's original. So if anything changes, when we copy it again to the Docker file, it's gonna compare these two thumbprints. And if there is anything changes, it's gonna just disregard the old one, it's gonna copy it again. So that's why here we can see when it's transferring to the context, it's a bit different from before, so it's gonna know that it's gonna need to copy everything again and basically run the release out again. I can't remember I remember the name of this, but it's something related to thumbprints. So
Works for me.
sorry?
Hash.
Hash, yeah, something like a hash. So the hash, which is generated the first time it copies it, and basically it's gonna keep a copy of that hash. If that, whenever I run it again, if these two hashes match, it's just gonna ignore it and just gonna take the new stuff. If these hashes do not match, it's just gonna recopy everything all over again. And that's what the context is. A context is basically copying everything from here inside our Docker container, a Docker image, excuse me. So once we have this running, and we have created a nice release of our application, now it's time to have the final Docker image that we want, and the nicest Docker image that we can ever imagine. So basically what we need to do is we need to do, again, from the base image, let's copy this. And this is not the best way, but I'll explain why I did it right now. So if you can see here, this is .NET 6 SDK. An SDK is very, very big. It could be up to like a 200 megabytes. And if I want to have an SDK inside my final image, which is not good, it's similar to having it as a server. Luckily, if I go to Docker Hub,
Don't you want the runtime?
execute, exactly. So instead of having here the SDK, I can put the .NET runtime, .NET 6 runtime. And basically here, instead of putting SDK, I can put here runtime. And basically, whenever I put the runtime, if that size of my SDK is 200 megabyte, the runtime is gonna be 15. And it's gonna dramatically decrease the size of my image. So let's put it for now SDK so we can see the sizes of the images once we finished. And then we can change it and we can compare. So right now I'm creating the last one, my final image. And basically once I create my final image, what I need to do, I need to create a folder which is called work directory, and pay very much attention to formatting. We're gonna call it called app. And once I create my folder, I wanna copy everything from the previous image to this new image, which also gonna utilize the copy keyword. And dash from. These are keywords provided from Docker. We have to learn them. There's no way around them. And basically from telling us from which folder to which folder we want to copy. I just want to tell it, from the build environment, which is the name of my previous image that I have. And I want to put it inside the root directory here, which is called app. And I'm going to put it inside out into my root folder. So basically, I'm telling it here that you need to check for a build image called build environment. And from this one, you need to look into the app folder and you need to look for the out. Because here you can see we have published it to the out folder. And then whatever exists inside this directory, you need to copy it to the root directory of this new image that I'm creating here. And once we have that, finally we need to specify the entry point, which is the main thing that I want to run. So right now, I'm just going to do a normal .NET build, a very simple .NET build. And whenever we do a .NET build, what's going to happen? Inside our bin folder, we're going to have the latest version of the DLL, right? So if I go here, basically you can see here that my main file is going to be leads.dll, which is the name of my application. So in order for me to run this, I need to have leads.dll. So what shall I do here? I need to specify my entry point to leads.dll. So it's going to be entry point, and let's remove this. And basically, what's the keywords? If I want to run any .NET application, it needs to start with .NET. So I need to put .NET. So that's the command, and then I need to specify the file. And then here is going to be leads.dll. As simple as that. So once I have all of this, now I can run my container, run my image. So docker build, and specify this, and let's run this. So now let's pay not build, sorry, docker. Not .NET build, Docker builds. See, whenever you Docker and .NET start with both with D. So right now, just before we check all of this, everything is cached. Here it copied all over again because it took the build environment. See, even like the copy of the CS approach is all cached. It's copying from the build environment. It did all of the releases. It basically copied everything from the build environment out to the root directory, and basically it told me that my image is ready, and this is the name of the image. Not a single human being is gonna remember this name. So what do I need to do to make it easier for myself? I need to tag it with something like more human readable. So when I'm actually building, I can put the -t, which is tagging, and I can call it leads. And then I can put the dot. The dot is really important. It's telling it like you need to look for the Dockerfile here. So if I do this, we can see everything is cached because I didn't change anything. I did not update anything. Everything is still the same. So basically Docker knew, okay, it's the same image as before. All you're doing here is just tagging it. So as we can see here, once it did all of this, once it has this unique ID, it basically tagged it with leads. So right now, if I open, for example, here, my Docker management dashboard, and I look at images, one of these images here, it should be leads, which is I just created, which is created 1 minute ago, which is pretty cool. So as you can see here, even the naming, it follows certain convention. So we can see here it has docker.io, which basically referring to the Docker Hub, and has the library because it exists inside my libraries on my machine, and has the word leads. You might think to yourself, okay, that's really nice. How am I gonna run it? So again, we have to utilize, because we're running Docker, we have to use the Docker keyword, and we need to put the run keyword, and then I need to specify which image I wanna run. So I can actually put this entire, but no one's gonna put it, so I'm just gonna utilize the tagged word, which is leads. And basically you can see that a similar when I run, because this is really cool. So let's have another portal. I'm just gonna put .NET run. Look what happened with .NET run. Oh. So in .NET run, it had to build it, then it had to execute it, and then show me all of this different information. Inside Docker, you can see there's no build. It directly ran it because it's already built and ready for us. That's a really nice thing, and automatically allocated a port, so on and so forth. So let us compare these two. Let us stop this because it's gonna drain the battery. It's already gonna die, but let's see. So this application is .NET 6, and this application here is .NET 5. What's the main difference between these two? This has 5 and this has 6. That's the main difference. Same logic, same code, same everything, except that this is a 5, which is referring to .NET SDK 5, and this is referring to .NET SDK 6. This application architecture is different because this is utilizing the new SDK, but this is here, I'm speaking purely from a Docker point of view. We're just changing the environment number. And if I want to make this even more optimized, instead of having an SDK here, I can put runtime. Is it runtime? My memory is really bad, I think so. Yeah, runtime. Save. Because I changed this, I need to rebuild it. So I need to put docker build -t leads dot. It's gonna build everything again. Let's make it bigger. And right now, let's see what happened. It did everything up to the cached, but because we are utilizing a much more, only a runtime version, it actually copied everything all over again, and it created a new image. But you might see here, okay, excuse me, you might think, okay, but it's called Leeds, and the previous image is called Leeds. What happened to it? Because we did not specify any versioning, it automatically overrode the previous one. If I want to specify a version, what I can do is I can put this column and put version 1. As soon as I put version 1, it will automatically know there is different version of the same image. So let's say I publish this image and it goes perfectly. Everyone can see my weather. And after 2 months, I discovered there's a major bug. And I released a new version. And within the new version, there's a major bug. If I want to revert back, all I need to do is just change the run from 1 to 2, and it will automatically be able to revert back to a previous version. And right now, if I do this, it has automatically created a new image with this new versioning. And if I had to go to my Docker here dashboard, if I go to images, if I scroll down, I can see leads, but I can see here the version. This is version 1, and this is the latest. I can add version 2, version 3, as many as I want. And basically, this is it. Any questions?
I was expecting to see lots of temperature data scroll down the screen.
Oh yeah, do you want to execute it? Yeah.
I need proof it's running.
Okay. So Docker run leads. Docker run. Okay, so we need to put leads v1. Let's execute, put back the SDK. Okay, let's go back to so we need to change the ports. And right now it might not work, and I'll explain why it will not work if in case it doesn't work. It will not work. It took too much time. Why it did not work? That's a very valid point. Thank you for pointing this out. The reason it did not work because as a container, it's running in isolation, and as we said, nothing can be able to interfere with it. When I run it on my machine, it's taking full advantage of my network card on my machine and basically network infrastructure, so it will able to automatically assign ports and able to connect to it. The reason it's not working is, what I need to do is I need to specify a port from the outside to the inside. I need to specify a port from the host machine to the actual container itself. So, one thing I like to do, let's put Docker run leads, so before leads, run. I put -p, which basically I specify the port, and I specify port 8080 to port 80 inside this machine. Did we expose a port here? We did not expose. So let's expose a port here. Which port I want to connect to inside this container? I want to expose port 80. Tell you what, let's put 8080 as well inside. So right now, what I'm doing is I'm telling this image that whenever I run a container from this image, you need to have this port 80 available for me. So we need to rebuild it. So .NET build -t leads. So this will take again a few seconds to complete, and basically it's completed successfully. So now if I run docker run -p 8080 from the outside, or 8081 from my host machine to 8080 inside the container itself, and I put Leeds, and if I go here, let's see if it actually connects on port 8081. It's not connecting.
Is it the version?
No. Let's think of this. What was it? There's a way. Okay, let me see. Program. So let's use this one. So let's use the web builder. .use URL. It's not available in .NET 6. Let me find it. Web host .use URL. Yeah, I'll specify HTTP star on port 8080. Okay, I'll explain what I'm doing right now. So when I run the .NET, okay, I'm sure as all of you know, inside my application I have the launch settings, and the launch settings basically, wherever it tries to run, it will automatically identify a port and the environment that it runs to. So even IIS Express is automatically part of this. I don't want that. I don't want automatic port allocation. So what I want is I want my container to automatically have my application to have a specific port, so I can always connect to that port. So right now, if I write .NET run, as simple as .NET run, let's take a look at the ports, what's going to happen here. Still, did I save it? Yes. Let's remove these. Oh, because it's taking its development. Okay, let's remove this. Okay, so we can see here it's automatically now connected to port 8080 because I forced it to connect to port 8080. So if I come to this one and I execute it again, but with port 8080, it should work. Oh, it's HTTPS, it should be HTTP. And it worked because it's utilizing port 8080. So now, if I run my container again, and it actually built, and now if I put Docker, run -p, connecting from port 8080 to port, I turn off, to port 8080, and I put Leeds. Now we can see it's connected to port 8080, and we can see the application is running through Docker on port 8080. So the main issue that was going on, inside my property, there was the launch settings. It was different port allocations. So whenever I remove those ports and I specified a hard-coded port, it's not hard-coded, it's the port that I wanted to. When I build that image, it will automatically know that which port it needs to be exposed. And basically, when I run it, I specify from which port from my host machine, it will actually communicate with that port inside my inner machine, and we can see all of my temperatures as actually showing as it should. Great. That's it for the demo. Do you have any questions regarding this?
I can see how this all works from a deployment point of view. I can definitely
Yeah.
see the power of Docker, but could you actually use it during the development phase of the project?
Yes. So the utilization from developer is, for me, I utilize, for example, in any company, you have different services you integrate with. So instead of connecting to those live services and actually messing around with them or you want to change anything, you can actually just get a Docker image of that running locally and actually utilize it for development. Or if you have an API you're trying to connect to, it makes much more sense to have that API locally so to avoid a lot of the traffics and the configuration, so on and so forth. That's one aspect. Another aspect, a lot of the stuff that goes to QA, it does not really need to be deployed to an actual live server, so you can try it. If you create a Docker container for them, and they can actually just execute that container on their own machine to make sure it passes the test, it's way much more resources friendly than actually having to go through the deployment process entirely for them to see.
Can you, for example, set a breakpoint inside a Docker image? Can you debug code inside a Docker image?
Yes, if you're using Visual Studio 2019 and forward, you can actually specify a breaking point and it will debug it. On Mac, it's much more limited when it comes to .NET, but if you're using Windows, it's much more easier.
Thank you.
Any questions?
The source code, it's copied at the first stage of the Dockerfile.
Yeah,
Will it be there inside the images?
it will be inside the image. It copies everything. I'm not sure in the latest one if it's actually copied the Dockerfile inside. I think it automatically ignores it because it knows it's a native file for Docker, but other than that, it will copy it. Something I forgot to mention, you know, in GitHub, we have something called the git ignore, where it's basically all of the files that we don't want us to comment on the server. Docker has a similar concept. Because the last thing when I'm copying images and I have an application which has thousands of code and hundreds of libraries, is to copy my bin and object file to my Docker container. That's gonna take a lot of resources. So if I want inside my root folder, if I put a new file, I can specify .docker ignore, and this .docker ignore is gonna function similar way to like a git ignore. So inside here, for example, I can just put, for example, arrow1 to copy obj or bin files. So whenever I'm copying anything, the contacts will automatically ignore the obj and the bin file, and they will not gonna get copied there. So that's something really also interesting. So we can keep even the images more smaller.
Great.
Great.
Thanks for that, Mohamad.
No worries. Thank you very much.